Okay, we are going to do topic 8.9 and 8.10 today. Were this a regular year, I'd spend a lot more time on this stuff. But with the way it's going right now, I just kind of want to touch base with it so you can see it. Because if you take calculus later, you will see it. What we did the other day is we took known cross sections like triangles or rectangles or squares or something like that, and we came up with a volume of a weirdly shaped object. Now we're going to do the method I like the best. It's called the disk method. And basically, what you're going to do, like if I take this rectangle right here, this blue rectangle, it has a width and it has a height of r sub x. If I take it and I rotate it, it's going to make this disk shape over here. And you all know when you have a disk shape like this, if I look at the front surface of it, this is just a circle, pi r squared. So what we're going to be doing is we're going to be using pi r squared to find the areas. And we're just going to take a shape. We're going to rotate it about the x-axis or the y-axis or another line to find the volume of it. So we got a couple of formulas that we're going to be able to use. And what we're going to use here for the disk method is these two right here. So you got the horizontal axis of revolution. That's when you're rotating it about an x-axis. Now, it might actually be the x-axis, or it might be y equals 1 or y equals -3 or something like that. But this is your equation. Your volume is just taking the integral of the area. So you just basically got pi r squared. That's all this is right here. This is your left-hand side. Your upper bound is your right-hand side, just like we used before when we were finding an area. And what we're going to do is we're going to take this shape and we're rotating it. And we're doing this all the way from A to B. So we're going to have a bunch of disks getting rotated, and we're going to add them all up. Kind of like you ever seen like one of those big long things of cheese at the store that are round shaped. It's like that. We're just going to keep slicing it, and then we're going to add up all those slices together. Now, most of the time, it's going to be like this. Most of the time, we're going to be rotating it about the X. Sometimes they rotate about the Y. And if they rotate about the Y, what you'll notice, it's just the flat surface of it, the small, like I don't know what you call that, the delta X, delta Y surface, it's always flat against it. And our rectangle is just going to go this way in our bounds, lower, upper, and then we're just going to take the radius squared again. And that pi is always out front. Whenever you do the disk method, you just slap a pi out front because it's pi r squared. I don't ever put it inside the integral because it's a constant. So the less I can have inside the integral, the better. But these are just our two general forms. And now I thought the best thing I could do is give you 3 examples. Okay. Do I need to wait a minute or can I move? Thank you.
Please can you wait a minute so I can.
Oh, okay, sure. Well, that makes me feel good. Somebody's writing it down.
I'll wait forever. You're good to go on, Mr. Shea. Thank you.
Okay, you're welcome. Anytime. Okay, so here's our first example. Using the disk method, we want to find the volume of the solid formed by revolving the region bounded by, and they have to give you your f of x, okay? So they're giving us this and the x-axis. So we are taking the shape. Let me see if my board's working better today. I worked on it for about 2 hours yesterday trying to make it look better than it did yesterday. Just getting that little, see my little spot thing again, that little thing right there, just getting that back again. I was so excited. So we're going from here to here because it says from 0 to pi. And it won't always say that. Sometimes it'll say the region bounded by the intersection of the x-axis and the function. So we're looking at this area in here, okay? So what we're going to do basically, it's like we're going to take it, and I'm going to try my darndest. Maybe I can do it this way, put a rectangle in here. I'm going to put a little rectangle in here. Your rectangle, the smaller side of it, always goes against what you're rotating about. So we're rotating about this like this. So this is going to come out of the screen towards you, go back in the screen, and it's basically going to make a circle. And what we're going to do, all the circles that we get in here, we're just going to add them all up. So I'm going to come over here. I'm going to go from 0 to pi. because that's the bounds it gave me. I'm going to put the pi out front because it's pi r squared. And I'm going to have a dx out here. So basically what we're looking at here, if we look at this rectangle is the radius. Like if I had a little rectangle for this one, that's your radius. So you're going to come in here and you're going to say the square root of sine x, all of that squared. So then you got your pi. And now, your square root and your square cancel each other out. So now you got to think again, what do you got to take the derivative of to get sine? I know it has something to do with cosine. So I just always go ahead and I write my cosine down. But if I take the derivative of cosine, I get a negative sign. So that means I got to put a negative out in front of it. So I'm going to take the negative out with the pi. And I'm going to say cosine of pi minus cosine of 0. So cosine of pi is -1 minus cosine of 0 is 1. And we end up with 2 pi. So that would be the volume. If I took this thing and it would end up, I wish I could draw it cool. It would end up looking, it would come down something like that. And it would come out fatter in the middle, closer in on the sides. I've got a picture of my next one that shows it a little bit better. But this is all we're doing for the disc method. Any questions for me?
And that's the area of
That's the volume.
Okay.
The volume of the solid shape we made by revolving that shape around the x-axis. And the next one has a better picture of it. Okay, so if there's no questions about this one, I'm going to jump to the next one. Oh, one thing I do want you to notice, it's really, really super important here. Whenever you're rotating it, see how the whole shape is flat against what you're rotating it about? Tomorrow we're going to talk about what happens if it's not flat against it. But this is all you have to do. If the whole shape from lower bound to upper bound is flat against it, this is what you got. All you got to do. Okay? Yes.
Is it absolute value? Like if there were negatives in it?
It shouldn't be negative unless you get your bounds backwards. Because if you notice, I was kind of freaked out by this negative right here. Yeah. But because when I put these in, the two negatives cancel each other out. The only way you should get it negative is, again, if these are backwards.
Okay.
Okay.
Thank you.
You're welcome. Okay, let's take a look at this next one, because this next one has a prettier picture. On this one, we want to find the volume of the solid resulting from revolving the portion of the curve. So they're giving us our function. They're giving us our bounds about the y-axis. So this is the 2D shape. Okay. So with this 2D shape, we're taking it and we're rotating it about the y-axis. And this is kind of like the 3D look of what it would look like. So I like this one because it kind of showed it a little bit better. We are going to come in here. It's a good idea to come in here and go ahead and put your rectangle on there just to get an idea. Make sure that you know which way you're rotating it. So we're going to come up with a bunch of discs that look like this one. They get smaller as they go up. They get bigger as they go down. So I've got my pi out front, and if you'll again notice, we're flat against the surface we're rotating about all the way from the lower bound to the upper bound, lower bound to the upper bound. And this time, if you'll notice, they gave it to us like this. They gave us y equals 2 minus 1/2 x squared, but they want it rotating about the y-axis. So what we had to do right here is we have to take this and we have to solve it for x. So if I go ahead just real quick, come over here and solve it for x, even though they've already done it, I kind of want to talk about it. Y minus 2 equals negative 1/2 x squared. I'm going to multiply everything by the reciprocal by negative 2. If I do that, I get a negative 2y plus 4 equals x squared. And then x equals plus or minus 4 minus 2y. So you know you have to put the plus or minus on there, but because of the picture they showed us, and because we are going from 0 to x equals 0 to x equals 2, That's from here to here. That's telling us we're going to take the positive one of it, not the negative one of it. If it was from -2 to 0, we would come down here and pick the negative of it. So make sure you understand that. Because for whatever reason, they like to make sure that you know which piece you have to use. The nice thing about it is if you use the wrong piece, you're still going to get the right answer because you have to square it. But you might lose that setup point. So I'm going to come up here, put my 4 minus 2y dy. And like I said, a lot of times you get a point for just setting it up. So ask me questions on that part. Let me ask you this. If you did not have the picture, if you did not have this picture and you did not know this bound went from 0 to 2, how would you be able to figure that out?
It tells you in the question.
No, it doesn't. In the question, it tells you from 0 to x equals 2. It tells you this. It doesn't tell you that. Sneaky, isn't it? If you don't have the picture, think about, we got our equation. Everybody's okay with the x equals this, right? We got our equation. But what we have to think about now, what would x be if we were against the y-axis?
0.
Right? So 0 equals 4 minus 2y. Square both sides. So we would get our upper bound right here. And we know from the shape, how do we know to stop it at the x-axis? This problem probably should have some more information to it because it doesn't say bounded on the x-axis. Revolving the portion from 0 to x about the y-axis. Yeah, really this problem needs to say also bounded by the x-axis. Otherwise, you know how parabola goes. It would keep going down forever. I just want to show you, if you don't have...
It says from 0 to 2, though, so it tells you where to stop, so it doesn't
What?
go below that until after 2.
Oh, duh, you're right. Okay, so we're good that way. I'm overthinking it.
Hey, Ms. Fisher.
Yeah.
You want to know another way to tell the upper bound of the
Sure.
function? It's literally just the 2 in the equation, because that's your constant, which is where it would be when.
If you recognize that, that's another good way to do it, because if you come up here and you put a 0 in here for x, you get the 2. Yeah, that's good too. I just like to show you guys, how you always can set stuff equal to find what you need in there. But he's exactly right, because of that right there, that 2 right there, you've got that coming down, and with it, this is an upside down parabola, that's all it is, that is going to be your vertex point. But anyway, it's just some things to think about as you're doing it. But back to just what we're doing. What's nice about these, if it's a square root and a square, you got your pi out front, 4y minus y squared. So
Does your direction of rotation change anything?
Does your what?
Does your direction of rotation cause anything differently? Does it make it?
No, it doesn't matter, because I know, I did that on purpose. Even if I say anything, it originally looked like this. It was rotating this way. If you rotate it backwards, you're still going to get the same shape. So you're okay. And your answer for this one's going to be a 4 pi. Whenever you have the disk method, pi is always in your answer. Always, always, always. Okay, so that's a second example. The only difference between these two is this one's against this one, and the first one we did was against the x-axis. They'll give you a problem. I think that's the way it is on the homework. They'll give you a problem, and they'll ask you to rotate it about the x, about the y, about a line. There's a bunch of different things they're going to ask you to do with it. What you need to realize with the disk method, it is flat against what you're rotating it about, because tomorrow we're going to talk about the washer method where it's not. So let me show you one more, then I'm done. Okay, the last thing I'm going to talk about is we're still calculating the volume of revolution, but we are going to do it about other axes. We are not doing it about the x-axis or the y-axis, but this really is not a big deal. That's why I thought it'd be okay to show it to you today. This is a lot of gobbledygook till you read it. This actually makes this a whole lot easier. So if you want to find the volume of an object generated by revolving it, about y equals k. All we did last time, that last example we did, was we revolved it about y equals 0. But if you're picking a number, like say we're going to revolve it about y equals 3. Okay, if we pick that, you're going to come in here and you're going to replace that k with whatever line you're revolving it about. So if I'm revolving it about y equals -7, I'm going to come in here and I'm going to put a minus -7. That's all you're doing with these. Let me see if we, I'll wait, hold on a minute. I'm just finished talking about this first before I get ahead of myself. Same way if you're revolving it about a y, x equals k. When we just did that last problem, our x equals 0, because if you look at what we did all along this line right here, x equals 0. So if you have these two, this one for anything revolving around a y, this one for anything revolving about your x, then it makes this simple. So I'm just going to show you one. We're going to look at this guy right here. Let me give you a second to write that down. Do you need that, Zachariah?
Thank you.
You're welcome. I get excited and get moving too fast sometimes.
You're good. I took a screenshot.
Okay, and again, don't forget, it's always saved. Now, I always put a PDF of it out there too if you just want to look through what what I marked on. Okay, so let's take a look at this guy. We're going to revolve about a line that is not a coordinate axis. So we're going to revolve this. So I'm going to come up here. I've got that. If I put in 1, I'm going to get 1. If I put in are y'all okay with me just doing this? Oh, well, pretend like, let's make that dot bigger. There. Okay. So all I really have to know is that it's a parabola open up down and its vertex is up there at 2. Okay. So that is this guy. Now we are also going to come up with another one. Our g of x is that guy. So find the volume of the solid formed by revolving the region bounded by the graphs f of x and g of x. So we are looking at this shape in here. So this guy in here is what we're going to be rotating. But we're not rotating about the axis. We're rotating it actually about g of x. So the first thing we have to do is we have to find our bounds. We have to find this guy and that guy. So I'm just going to say 2 minus x squared equals 1. I'm just setting f of x equal to g of x. So I'm going to take the x squared to the other side. I'm going to subtract 1 from both sides. And I've got my bounds, which I already kind of knew from the graph, but I just wanted to make sure. Okay, so now we're going to do the integral. We put the pi out front, and we're going from -1 to 1. Now, if we did it the old way, we'd be finding this area under here too. But because we're not rotating it about the axis this time, because we're rotating it about another number, we're going to use this right here. So we have our A and our B. Now, what I'm going to do here is if I'm rotating about this, I'm going to say 2 minus x squared, because that's what we're rotating, right? Minus 1 quantity squared dx. Are y'all okay with that? The lack of noise tells me either you're too confused to know what to ask or you're okay with it. Basically, the way I think of it, this -1 right here is what I would have to do to shift this thing. I would have to shift it all down 1, basically to get it to the axis. That's how I think about it when I put that -1 there. I'd have to get it back to my spot that I like. I like the axis. The axis is what I'm used to. To get it back down there to the x-axis, I would have to take that whole yellow shape and move it down 1. That's another way you can think about doing this.
Why do they have to specify g of x equals 1?
Because you really didn't have to. I was kind of confused when I first read the problem. You didn't have to. Really, all you had to say was what is enclosed by y equals 1 and 2 minus x squared. Now, what they could have done, they could have come in here and said about the line y equals -1. So you have to be careful there, because if you're going to do y equals -1, you have to make sure you have that encased in there. What I'm going to do is I'm going to put some more examples online. I just don't feel like you listen to me drone for another, half an hour would be necessarily a good thing. You just need to jump in and start trying them. And then tomorrow I'm going to expect some questions. Okay, so unless you've got work and stuff you're doing, if you're home bored, go ahead and get this knocked out so you have some questions for me tomorrow. But really, for the most part, I think I'm done. So I will have this saved. I will put some more stuff out there about this kind of stuff. Let's jump over and look at the assignment. So basically what we're going to do now is the ones that are flat against the axis are the ones you're going to do. And is it not going to load for me? My computer has been acting so wonky today. So what it wants you to do, like this one, it wants you to graph it. So graph it and then put your axis of rotation about it. So for this one, we would be up at 4, we'd be going down like this. So it will be flat against the X, flat against the Y. So we could use both of them. We haven't talked about the washer method yet, so don't worry about the washer method yet. All they're asking you to do is to find the volume. They want you to put your radius in there. So you can probably do the disk method on any of them that says the disk method. And if you notice down here, they get away from it. So if it says disk method, go ahead and try it. But this isn't due until Friday, the whole thing. So some of it you can do, some of it you can't. Tomorrow, we will look at doing, not that one. We'll look at doing the washer method. Well, we might just knock it all out, so y'all just cannot have to worry about having class for a couple of days. We'll see how it goes. We'll do this on Wednesday and possibly this on Thursday. We'll just kind of see how tomorrow goes. But I will be putting some more information out there to help you guys out on it. So any more questions for me before I sign off?
Ms. Fouché.
Yeah.
Could you stay after for a bit, because I need to talk to you about a physics thing in particular.
Okay. That is good with me. So otherwise, guys, I am good to go. If you all want to start beeping off and leaving me.
Ms. Fouché,
Yes.
I really wanted to say thank you.
Oh, you're welcome. I wish you could stay with us. I wish you could have had a normal year with us. You're going to make me cry. I'm doing my eyes. Best of luck. Okay, Ellen?
Yeah,
We'll
you.
always remember you're welcome. Take care of yourself.
Yeah.
Okay, bye.
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 We'll miss you, Ellen.
Yeah.
My heart.
Good luck, Ellen.
Hey, you can still
Good
be on
luck.
Discord. Still be on Discord and come see us, okay?
Yeah.
Okay.
Right.
We'll still be around. You can come listen to me if you want to, okay?
Okay.
Okay, take care of yourself.
You too.
Okay.
Bye.
Bye.
See you, Ellen.
Oh, God. I'm going to cry. This sucks.
Tear it up.
Shoot.
I don't even know who she is. Come on.
Oh.
You're supposed to feel